All right, thanks for joining today. So today we're going to talk about Kubernetes as infrastructure. This is just I'm just redelivering a session, which for the PowerPoint for this is already available in the presentations folder in SharePoint. So essentially, just want to idea for the session is to go over how you can explain Kubernetes to customers, primarily who are in the infrastructure area, and without delving deep into the development aspect of things. So what I really want to start talking about is about a container. So I think this is most of the folks who are going to be listening to this call would know what a container is. So when you think about a container, the idea of a container is you take, let's say if you have an application and the application has got a bunch of dependency to it, and if you want to deploy the same application in the same server, the idea of having all these dependencies and the fact that, let's say, if you have one API trying to, there's one version of the API which one application is trying to access, and there's another version of the API, another version application is trying to access, that cause conflict. So the development world came up with this idea of abstracting that out, in abstracting your application into a container. They just borrowed the idea from a typical shipping container concept. So the idea here is instead of running these applications in a virtual machine, you put them into a container, and the container itself will have the application and its dependency, and it runs within a container engine. There's a container engine which runs on your guest OS. And one of the most popular container engine is Docker. Obviously, there are other container engines. And essentially within Docker, the way you define a container is container itself has got the concept of an image. And you typically want to, when you create a container, you start from an image. And like, for instance, Alpine is a very base image to start a container with. You can think of it like an operating system. And then you define your container with respect to what command you want to execute and where do you want to start with. There's a bunch of basic definition you want to define. And this is how you define a container. And this is defined using Docker. And then there's a bunch of Docker itself is an engine, is a container engine. And then what you use is you use Docker command line tools to create this definition. And when you create this definition, that's how you would define what a container image is. And I just went through some of this in the last session. And we also spoke a little bit about container registry. So once you have containers, you can put these containers into what we call as a container registry, right? So the idea is you push your container images into a container registry. And let's say if I want to run a container, I pull an image from that container registry and run it. Like for instance, let's say I want to run SQL, I would run the image from a SQL image. I can pull it from the Docker Hub, which is a registry, and then I can run my own container from there. So, so essentially, very popular container registry is Docker Hub. Azure has also its own private container registry called Azure Container Registry. Okay, so now that you've got containers and you got a registry, how do you run these containers, right? So let's say if you have multiple containers, and you want to you have a whole bunch of containers which you're running, but the question is, how do you load balance these containers? How do you make sure that let's say if you have multiple containers running, you want to be able to auto scale it. For instance, you may want to make sure that if you want, let's say if you want to implement a microservice type architecture, you might want to have some auto healing capabilities. So how do you do that? How do you run containers at scale? And that's when this whole notion of container orchestration came into being, right? So the idea of container orchestration is, hey, you got all these multiple containers running. So how about if you can run all these containers in multiple virtual machines and call it a cluster, and then you got a master orchestrator which orchestrates the idea of load balancing these containers, the idea of self-healing and all those things. So that's managed by this master. Now, when you think about container orchestrators, there's a bunch of leaders in the marketplace so far. So there was a company called DCOS, there's Docker Swarm, but right now Kubernetes is so far the biggest champion when it comes to container orchestration. So essentially, Kubernetes is a open source and open source container orchestration, which started with by Google, but it's become very popular and has been adopted by multiple cloud vendors. So the again, Kubernetes has got a very similar concept. It's got a master and a cluster. The cluster itself, we call it an agent, and that can have multiple nodes running in it. So that's a high level view into that. So if you think about Kubernetes, if you go down one level deeper, you got a cluster, and within the cluster, you got multiple nodes running, and each of those nodes have got a whole bunch of components. Like for instance, over here you see kubelet, kubeproxy, and all of this has got a purpose, which I'm not going to go into level of depth because in a sense, all those things which you see there is not really that relevant for somebody who is running Kubernetes. That's all Kubernetes internal concepts. So the idea here, but one thing maybe you may want to keep in mind is when you run, if when you want to interact with Kubernetes, you use something called kubectl or kubectl. The people call it different things, and that's you really accessing the master, and then that's a tool which you use to work with Kubernetes on. All right, so now earlier we spoke about containers, right? So we said that containers is how we abstract the applications and its dependencies together. So where does this containers go in a Kubernetes architecture? It goes into what we call as pods, and pod is nothing but it's a unit of work in Kubernetes, and each pod can contain one or more containers, and they are always scheduled together. So when you think about uh, Kubernetes architecture components, you got multiple nodes, just like I said before, but that can have multiple pods running in it. So the pod itself is running within the nodes. Now you can have pods spread across multiple nodes in any way you want into whatever definition you define. But essentially, what is pod? It's just metadata, right? It's a metadata that describes how a containers are configured. Like for instance, over here, what this pod is saying is pod has got a label and it's got a container image. So this is the container image the pod is going to pull to create that pod, and it's got a port, and it also has got a volume mount, which is where essentially, let's say if the pod needs to have some persistent storage across multiple pods, it can use a volume mount. So essentially, it's just a metadata which is defining how the containers are configured. Now, you can have multiple pods running. So you got over here, you got ratings web, ratings API, and you can also have multiple and maybe any other application here. All of them have got a container image and a label and a port associated. So essentially, it's just a metadata describing the container image and what port you want to run in, and what is the volume mount it uses. So that's pod, and that's how we define a pod. And another concept is what we call as deployment. And deployment is something which you define in declaratively in using metadata. And what is that? It's essentially a metadata that describes how to deploy a pod. So over here, you got a deployment definition saying that, hey, I want 2 replicas of a pod, and that is essentially defined in a deployment definition, and that is something which you define using a YAML file, YAML file, and that's how you define. Say, hey, I want 2 pods, and the pod looks like this, and I want 2 replicas of this pod running in my Kubernetes cluster. So just to show this in action, so you got a deployment pod configuration, which is a YAML file, which you which you deploy into the master, and once you deploy it, that's when it starts spinning up the pods which you have defined, right? In this case, there's 2 pods running, right? There's the ratings web. In fact, it's 2 instances of a pod which you defined that you want two instances of the pod running, and it spins that up. Now, let's say you said that you always want 2 instances running, And if one instance dies, it automatically brings up the other instance. And this is what we call as desired state of Kubernetes. So essentially what you're saying is at any point in time, you always want two replicas of the pod running, and it keeps and whatever happens, it makes sure that the two replicas are always running. And let's say, for instance, the whole node went down. What it does is it actually brings up that pod in the other node. But as far as Kubernetes is concerned, it by itself, it does not know how to spin up a new node, and I will talk about that in how we can do that in AKS. But that's not a Kubernetes does not it can only work within the limits of what Kubernetes can offer, right? So, but this is what Kubernetes does. If the node goes down, it spins that up within another it spins up the pod in another node. So another concept which is important to understand is this notion of services. Again, it's just a metadata definition, and what services is you can think of it almost like a load balancing for your pods. Like for instance, you got two pods, instances of a pod running, in this case, ratings web 1 and web 2. And you want to have one single entry point to all these two pods. And you do a pod mapping, port mapping from that service into the containers which are running inside the pod, right? And this could be internal or external. Like I got an upcoming slide talking about different types of services. So, but essentially it's just metadata which describes how to reach the pods, right? That's exactly what it is. But essentially, let's say if you have two pods running, you deploy a service configuration, you have one IP address to which you point to, and then you would talk to that service, and then that way it internally talks to the multiple pods. So you're not talking to the pods directly when you use a service. Okay, so the other interesting thing is how you deploy your pods using or deploy in Kubernetes. So essentially, there's multiple ways you can deploy whatever. I talked about the fact that you can create deployments, and I spoke about how you can use kubectl to create deployments. But essentially, there's also a portal available within Kubernetes which you can use to deploy. Let's say you have from here. Let's say if you have a container available, you specify the name of the container image from, let's say, an Azure Container Registry or Docker Hub or wherever that is. You can specify the URL of that, and then you can click deploy and it deploys. That's one way to deploy, or you define everything within a YAML file and deploy it that way. So our recommended way is to go via a YAML file, because that provides much better automation, and portal is definitely not recommended. All right, so the next thing is scaling a pod, right? So how do we make sure that you can scale? And I kind of touched on that a little bit earlier. So again, you can it's defined within a deployment file. So you want to say that let's say if you say that you want to have 6 pods running across multiple nodes, and let's say, for instance, in this case, you have 3 nodes, and let's say one of the nodes went down. Or what you could do is in AKS, you can actually spin up scale the cluster by adding the nodes, right, by a command line. So that's one thing to do. But one of the recent thing which we also rolled out is this notion of a cluster auto scaling, which I have not covered here. So you can actually auto scale the cluster as well. So in this case, you are manually adding the nodes via a command, but it takes some time to spin that up. It's not instantaneous. It takes some amount of time to spin that up. So what's the other option if you want to spin up? Let's say if you want to scale it out, right? So you don't really want to spin up the node. You don't want to take it that much time to scale out, and you want to have an instantaneous scale out. So what you could potentially use is this notion of Azure Container Instances. And that is, so Azure Container Instances can basically extend that pod, and you can extend the pods into Azure Container Instances using what we call as a virtual node and the virtual kubelet. That's the concept which it uses. So essentially, as far as the as far as Azure clusters Kubernetes is concerned, it just thinks of it as another node running in another pod, but it uses a virtual node concept to spin it up. So so essentially what it internally does is it uses the Azure Container Instance to spin up scale out your pods into the Azure Container Instance. Okay, so I think I did that. And the other interesting thing is how do you do updates and rollbacks? So there's a couple of interesting options. You can do updates again using a deployment file. So one is called blue-green deployment, where let's say if you have a V1 of pod and then you want to deploy a V2 of pod, what you can do is you can have them side by side. So in this case, what happens is you deploy the V2 of pod, and this will be running side by side with V1. So when the user is accessing the site, they could either go to V1 or V2. But what you do is you just put V2 and then kill the V1 in each of the nodes and then make that available. So that's one way to update your pods. The second is what we call as green deployment, where you take all of the V2 and deploy them completely separately, and then you update the service configuration file, and then to point to the new set of pods. So that's how, those are the couple of different ways. Again, it's up to you on how, depending on the application, you can choose what would be the best approach to deploy or update your containers. And the other interesting concept is this notion of storage. So how do we store, let's say within Kubernetes, if you have some amount of storage which you require, one of the things you need to understand is the fact that anything which is in a container are ephemeral, in the sense, as soon as the container dies, the storage is gone. So how do we then store it, right? So there's multiple ways, multiple volumes within Kubernetes, and I'm just giving you all those different options. But the most important thing to note here is this notion of a cloud volume. So this is how we typically, like for instance, when you spin up AKS, you can specify what your cloud volume is, and in Azure, it uses the Azure Blob Storage to store your persistent volume. But similarly, AWS and Google, they all have their own persistent cloud volume based on their whatever the cloud offers. All right, so the so you can actually, again, this is just to give a little bit more detail on how the dynamic storage works. So as you can see, the storage class itself, right? So over here, it shows that the volume mount are in this mount path. It's basically all stored within Azure Blob Storage in the managed disk, as you can see in the bottom. The other thing is, other thing which is very important is networking, right? How does pods talk to each other? How do they communicate? So very important thing is the fact that every pod, it's by its in and itself, has got an IP address, and so this is one thing which causes a lot of concern for customers, which we need to plan upfront, because of the fact that every pod has got an IP address. When you create an AKS cluster in using, let's say, Azure CNI, which I'll talk about in a minute, you really need to plan out the number of IP addresses ahead of time, right? Which is kind of something which we need, and as part of the operational best practices, that's something we need to talk to our customers about. So we spoke about services earlier. So how does services work in the notion of how is it useful in the perspective when we think about networking? So let's say we have one pod, the pod dies, it's got an IP address. and the other pod comes up with a different IP address, and we don't know where that one is, right? So that's when the service comes in a picture, because as a client, you're only talking to the service, and the service internally load balances between the pods. So therefore, it becomes easier to talk to the pods. You got just one single entry point to talk to the pods. And when you talk about service, there's actually three types of services. There's cluster IP, which is internal, load balancer, which is external, and node port. Node port is something which you should never use, and that's a longer discussion. I'll save that to another time. But cluster IP itself is an internal load balancer. So you have the traffic coming into a proxy and a service, and then it load balances between multiple pods, and the net, and then the load balancer is another type of a service. Again, the biggest difference is it's external. And then there's also another notion of another layer of load balancing, right? So you talk about service, which is like an internal load balancer, but there's also something called as an ingress controller. An ingress controller is a layer 7 load balancer, and it's similar to what the application gateway offers, and service is similar to what the Azure load balancer offers, right? So it's the internal load balancer. I mean the layer 4 load balancer. So again, we have another, I believe, a new option of ingress controller which is coming out, which is based on application gateway. So it's a layer 7 load balancer. You can do URL based routing, and all those things which you can typically do in a layer 7 load balancer can be achieved using the ingress controller. When it comes to AKS networking, there's a couple of options. One is basic and advanced, and basic uses what we call as Kubernetes, and advanced uses use Azure CNI. So the difference is within advanced, you can use your own VNet, right? So you're deploying deploying it in your own VNet. So that's the biggest difference, right? So and it provides a level of security on top as well. And there's a lot of detailed. I think the biggest thing with respect to advanced is the fact that, let's say if you want to connect to some on-premises systems, advanced makes it extremely easier. With basic networking, you can do it, but it's very, very difficult to achieve that. All right, so the other, maybe some of the important things is how do we deploy, do CI/CD rollbacks, how do you update your Kubernetes? There is a company which Microsoft acquired called Helm, and we also have and that's a tool which you essentially, instead of writing the YAML files, becomes extremely easier when you use Helm. And in Helm, there's something called as Helm chart, which helps you define, install, and upgrade your Kubernetes application. So that's an interesting thing to understand. And then you should also, maybe one of the other interesting point to understand is how you could use Azure. There's something called dev spaces, which you can use in using Visual Studio, which leverages Helm under the covers, and it gives you an easy deployment option for Kubernetes. And there's a whole bunch of different monitoring options in AKS, which there is Azure Monitor for AKS, which is available in the keyboard. And there's also a whole bunch of third-party options as well. And lastly, I just want to talk about a couple of, if you want to get down a little bit more deeper into AKS, now that you guys understand the concepts. So there's this aksworkshop.io. What it offers is a full hack, workshop. So you can pretty much go in here and run this entire thing. So starting from building up the Azure subscription, it gives you an application, and then you can deploy Kubernetes, you deploy MongoDB, you take an API, deploy it, you deploy an ingress controller, and then you also play around with how can you do scaling. You play around with container registry. You also learn how to do DevOps, continuous integration, continuous deployment, and you You also use, remember I was talking about how you can scale your Kubernetes service using virtual nodes using Azure Container Instance. So this is something you can do here as well. So it's pretty detailed, and this is something which I recommend you guys can run this workshop for your customers, and they will get a full view into how to deploy end-to-end view into how to deploy AKS and how to manage it, how to operationalize it as well. And then there's also this other thing called What the Hack. I got the URL right here. So that's another workshop you guys can run. So that's about it.
That was great. Perfect timing.
Thanks, man. All right, so I'll stop recording at this point.